Now, this is the last question that we are going to see in projectile motion, and it is slightly different. So what we have is we have a projectile which is being launched from a height of 3 meters onto a platform which is 9 meters high. So if I want to draw it, I'll draw it like this. So this is my platform, 9 meter, and this is someone launching something from this point, and it goes like this. Right? Now initial velocity, now it's the diagram is not coming out really well, so just let me see. It's like this. Initial velocity is given as 33 meters per second, and the launch angle is 44 degrees. So part A is just asking us to find the range. Range is basically from here. This is the range here, from horizontal distance from the launch point A to the landing point B. All right, so very straightforward. To find this range, first we need to find the time of flight, and to find the time of flight, we will look at the vertical motion. So vertical motion, initial velocity is 33 sine 44, and that gives me 22.923 meter per second. And the fact that I have taken this initial velocity as positive here, it means that I have taken upward direction as positive direction. It is immaterial. What we have to do is we have to be consistent throughout the problem. So vertically upward direction is positive, so my acceleration due to gravity will be negative. And here I'm looking at vertical displacement from when the object goes from point A to point B. So vertical displacement from A to B is basically, it is telling you how much height is attained by the object when it goes from A to B. So A is at 3 meters, B is at 9 meters, so vertical displacement is 6 meters in vertically upward direction. And because vertically upward direction is positive, so let me be clear here that object is going from here to here. So displacement is vertically up, that means it is positive 6 meters here. The object has risen by 6 meters, and we need to find the t. Straightforward, we use the equation s equals to ut plus half at square. S equals to 6 is equals to 22.923 t minus half 9.8. This is minus has come from 9.8 here, but because equation has plus, but 9.8 is negative, so I have brought that negative sign here, times t square, which if I simplify, minus 4.9 t square. Now I'll write that as a standard quadratic equation, which is done like this: 4.9 t square minus 22.923 t plus 6 equals to 0. Basically, I have transferred these quantities from the right to the left. Now using graphing calculator, as I told you, this is a quadratic equation. You can solve it using quadratic formula as well, but chances of making a mistake in calculations is very high there. I would strongly recommend that you use a graphing calculator to plot this and then find the points at which this graph crosses the horizontal axis, the x-axis. So I would suggest that you write like this. You say that what you've done, solving using calculator. Write this so that teacher knows how you got the answer, and we get two answers: 0.2783 seconds, and other is t is equals to 4.4 seconds. Now if you look at this, so what this is telling you, these are the 2 point times at which your object is at a height of 6 meters from 3. Yeah, so this first time is when it is going up, when the object is going up, and second time when the object has basically landed. So our time of flight is t is equals to 4.4 seconds. So TOF is equals to 4.4 seconds. Horizontal range you simply find by multiplying this time with the horizontal component. So horizontal component is 33 cos 44 time with 4.4, and that gives you 23.738 times 4.4, which gives you 104.44. all right, that is 45. So this is the horizontal range of the object. Part B of the question is asking us to find the maximum height attained. So obviously maximum height attained means we are looking at vertical motion again. So let's again write here, this is my part B. I would suggest that you write that again, doesn't take long, just list the quantities, because if you list the quantities you will get an idea about which equation to use. So u is equals to vertical motion is 22.923 meter per second, a is equals to minus 9.8 meter per second square, and this vertical motion we are only considering from point A to point C in the diagram here, which is the highest point. Yeah, so this point here I'm just considering for part B, I'm just considering the motion from A to C. This is my point C here. So from A to C, A is this u is the initial velocity at A. Acceleration this A. Sorry, initial velocity is u, which is 22.923. That is at point A. Acceleration is minus 9.8, and at the end of that motion, which is at point C, we have vertical velocity is equals to 0, and we need to find the s. Here, at the highest point, the vertically the object becomes stationary for a moment before turning back. So when we look at this, we can see that the equation that we need to use is v square equal to u square plus 2as. Substituting values there. We get 22.923 square plus 2 times minus 9.8, which gives you 0 equals to 20. I got the values here, or I can just leave it like this, 22.923 square minus 19.6s. I transfer this to the other side, to the left side, and I get 19.6s is equals to 22.923 square. That gives you s equals to which will get as 26.81 meters. Now we have to be careful to realize that this is basically the vertical displacement from A. So this is not the height, this is not the actual height from the ground. So to find height from the ground, we need to add the height of point A. Height from ground is equals to 26.81 plus 3, which is equals to 29.81 meters. That is that's the height of the highest point that the object reaches, and it's the height from the ground. Now part C is asking us to find the projectile's velocity at t equals to 3.5 seconds. So as we discussed earlier, that the horizontal component of the velocity is always same, it's the vertical component changing. So all we need to do is we need to find the vertical component of this object at t equals to 3.5, and then we need to vectorially add that to the horizontal component. So vertical motion we are considering, and using this vertical motion we will find the velocity at t equals to 3.5 seconds. So u is equals to same that we already had earlier, which is 22.923 meter per second. A is equals to minus 9.8 meter per second square, and T is equals to 3.5 seconds. And V we need to find. This is the V at after T equals to 3.5. We can see that we need to use this equation, and that gives you 22.923 plus minus 9.8 times 3.5, which gives us minus 11.376 meter per second. Because the negative sign means that it is opposite to our positive direction. Our positive direction was vertically upward. This negative sign means here that this is the velocity vertically downward. Now what we need to do is we need to, this is the vertical one, and horizontal velocity we already know. Horizontal velocity is equals to 33 cos 44, which is basically 23.738 meter per second. Now all we need to do is we need to add this horizontal velocity with that vertical velocity to get the total or net velocity of the projectile at t equals to 3.5 seconds. So we draw them and vectorially we add them together. So horizontal, that's my 23. That's my starting point, and then I draw the vertical, and because it's minus 11.376, which means it's vertically downward, that's 11.376, and that is my final velocity v. Okay, I can write this here as vh, and I can write that as vb, and because I will need the direction as well, so just I'll keep this theta here. Now V is equals to, using Pythagoras theorem, because this angle is 90 degree, 23.738 whole square plus 11.376 square, and we get that as 26.32 meter per second. To find the angle theta, we use the trigonometric ratio 10, and we get this, which is 11.376 divided by 23.738, and that angle comes out to be 25.61 degrees. So we need to write the answer properly, stating the reference from which we are measuring this angle of 25.61 degrees. So we add 3.5 second is equals to 26.32 meter per second, 25.61 degrees below horizon. That completes our part 3.